All right, so what do we do when the chain rule meets with other types of differentiation rules? You keep in mind what your main plan is, or what I often like to call the blueprint, and you stick with that. And you just kind of adjust as the derivative calls for it. Let me show you what I mean. So here we're given a product, right? You've got 3t to the fourth times the square root of t cubed minus 5, and we're asked to find the derivative. So what do? We can't simplify it at all. But we notice that we're going to need the product rule, right? So I just kind of mark that down. I'm going to need the product rule. That's the overarching plan, right? So I do that, and that's what my brain focuses on. So I've got the first function times the derivative of the second. Now that second function can be rewritten as t cubed minus 5 to the 1/2. Keep that in mind. So first d second. Now my brain focuses completely on d second and realizes that's the chain rule. So focus only on the derivative of this. Then we'll come back out of that and see where we are in terms of the whole product rule plan. So the derivative of this is the derivative of the outside, copying everything else down, to negative 1/2, there's your power rule, times the derivative of the inside, which is 3t squared. Okay, now we pop back out and say, all right, I took first d second plus second, we're just going to copy that, it'd be t cubed minus 5 to the 1/2, d first, which is 12t to the third. Okay, and we stop there. That's what I would practice doing in these problems. Don't keep going, just keep practicing to that level, then go back and simplify. Strategy I've shown you before. Here, and I'll go back and I'll clean this up in a second, I want to show you the kind of strategy I'd use when doing these. Here, when we take a derivative, notice that the quotient rule is the overarching strategy. And then if other rules come into play, we'll deal with it. Now also notice that this is x plus 1 to the 1/5. Okay, here we go. So we take the derivative. That's going to be the bottom function. So I'll write that as x plus 1 to the 1/5 times the derivative of the top, which is 2x. Okay, so that's bottom d top. Repeat it to yourself so you don't lose where you are in the master plan. Bottom d top minus top x squared plus 2 d bottom. So now we get to d bottom and we realize we got to hyper focus on this because it involves the chain rule. So that's going to be the derivative of the outside, 1/5 times all the stuff in the inside, subtracting 1 from 1/5 is minus 4/5, times the derivative of the inside, which is just 1, right? The derivative of x plus 1 is 1. All over, going back to the quotient rule, the bottom squared. That would be x plus 1 to the 2/5 because you're squaring this. And that's it. I'd encourage you to practice the problems like this so that you're getting really good at overarching rules like quotient or product rule and then working in the chain rule where it comes in. Then go back and tidy it up. You can even take tests like this too if you need to. Why not? So now we go back and we simplify it. We've got a lot here to multiply, so be careful. 3 times 3 is 9. You've got over 1/2. Ooh, and I'm going to make it bigger because I know it's going to go over this. That's going to be t to the 4th times t squared is t to the 6th. So I've got the 3, the 1/2 accounted for, the other 3, t to the 4th and t to the squared, or t to the 2nd accounted for, and this is all to the 1/2. So that'd be t cubed minus 5 in the denominator, like so. Not bad. Plus, this, there's nothing we can really do to it. 12t cubed times the square root of t cubed minus 5. But again, take the derivative first, then move on to the next problem, then come back and work on your algebra. That's it. Square root because of the 1/2. Okay, I'm going to clean this one up a little bit, and let's see what happens. So I get h prime of x is equal to, I'm going to leave it in terms of the rational exponents. We're not going to change it to radicals here. So I've got 2x times x plus 1 to the 1/5, nice, minus, okay, well it's going to be minus 1/5 times that, so minus 1/5 times x squared plus 2. And if you want to, you could put that all in the denominator or keep it as x plus 1 to the negative 4/5, however you want to do it. Right? The 1 times that was just negative 1/5. All over x plus 1 to the 2/5. And are there other ways textbooks are going to simplify it? Sure. I'm more concerned with your ability to take a derivative and get to here. I got one more problem in this video for you. It's sick. We had product rule as the main idea with a little chain rule on the inside. We had quotient rule as the main idea with a little chain rule on the inside. Now we're going to have the chain rule as the dominant rule we're going to use with something else going on the inside, the quotient rule. You can handle this. So the main idea here is the chain rule. And the rest of what follows will follow. So I take the derivative of this, and I notice I've got everything to the third. So the derivative of the outer function would be 3 times stuff. The stuff being that gargantuan. We'll get to that. Don't worry about it. But there's no reason to get nervous about it. Just copy it. You're using the chain rule as your dominant rule. 3 times stuff to the second times, chain rule here is derivative of the outside times derivative of the inside. And quite possibly the worst part of this problem for me is writing the letters. So now we're going to do the derivative of the inside, which is this. So you're focused on that part and thinking that's the chain rule. So now your brain says, cool, this is a little side project. I'm going to do the, sorry, not chain rule. I'm going to do the quotient rule. So again, derivative of the outside times inside's derivative, which is quotient rule. That would be bottom d top. Well, that's at least 1. That's nice. Minus top. Who makes these problems, honestly? Me. Top d bottom, which is 2x. All over the bottom squared. Your brain is fully focused on this task right now. So these problems seem harder than they are when you first approach them, till you like them to the real world, right? You'll often have a major project that's due maybe for school, but there's lots of little components you have to do. So you're always keeping an eye on what you're doing on the whole project, maybe the whole paper that you're writing. But when you're writing a paragraph, you shouldn't be thinking about the whole paper all at once. You should be thinking about the words you're writing in that sentence. You write in that sentence and then you back out and say, oh, it fits nicely with the paper, or it doesn't work so well, or it's just going to have to fit. Here we're doing the same thing. The big picture, but then when the little part comes in, we have to focus on that little part. It can become big. And I'd rather you just leave your answer like that, right? There's no reason to simplify it out further. I'm going to do that in case your teacher wants you to, and I'll show you a strategy that will help. So I notice here that we've got x squared plus 7 squared and x squared plus 7 squared. But I want to be very clear. This is the calculus. This is all algebra left. I rewrite everything as 3 times x minus 1 squared over x squared plus 7 squared. Again, it's because I notice that I'm going to be multiplying this by that. Times. Let's simplify the numerator, right? We're going to do a little mental math here. This is going to be x squared plus 7, right? Just times 1, minus 2x squared. Not bad. Minus, and a minus 1 is positive 1 times 2x plus 2x. We combine everything together, and that's going to give us minus x squared, plus 2x, also plus 7. I guess plus 2x isn't that bad. All over x squared plus 7 squared. That's nasty. But don't let the algebra fool you. That's not the calculus part of this, right? So now I just keep everything in factored form, because if you're ever asked to find the zeros of this thing, this will lend itself best to that. And it's easy enough to plug in x values as well. So I just copy the top, multiplying across. The denominator is going to be this raised to the 4th. And then you're done. You can wipe your hands of this problem. Beautiful, beautiful stuff. Awesome. So these are the more advanced type of chain rule problems. In the last video in this lesson, we're going to go over the chain rule as it is involved with trig. Stoked for that. You know it. Peace.